Problem 59, we're taking a look at some inequalities. We want to represent them on a number line. So the first one, I want to find my boundary point by switching this to an equals symbol. So I have 3 times 2k minus 1 equals 9. Distributing the 3, I get 6k minus 3 equals 9. Add the 3 to both sides, and I get 6k equals 12. And dividing by 6 to get k by itself, I get k to equal 2. So that is my boundary point. The symbol we have here is a less than symbol. It is not or equal to. So I have an open circle because it is not or equal to. On my number line, if 2 is there, on the left side of it would be 0. I'm going to test 0 in the original inequality. So I have 3 times. If I put 0 in for k, that becomes 0 minus 1, or just negative 1. Is that less than 9? So negative 3 less than 9? That is true. So that means it is true when I tested 0, so I shade towards the direction of 0. That is my answer on number line. If I did want to represent it with an inequality, my answer would be k. I'm going to the left, so it's less than, and my boundary point is 2. Let's take a look at problem B. I have 2p over 5, and I'm going to set it equal to 6 to find my boundary point. Multiply both sides by 5 to get rid of my fraction. I get 2p equals 30. And solving by p, for p I divide by 2, and p equals 15. So on my number line, I have 15. My symbol here is less than or equal to. Since it's or equal to, I'm using a closed circle because I'm including 15 as my part of my solution. So I'm shading 15. On my number line, 0 would be to the left of 15. So I'm going to test 0 to see which way I shade. So 2 times 0 over 5, is that less than or equal to 6? 2 times 0 is 0. And 0 divided by 5 is still 0, so I get 0 is less than or equal to 6. 0 is less than or equal to 6. That is true again. So I shade in the direction of 0. That is my solution on number line. So P, going to the left, is less than, closed circle, so it's or equal to, and my boundary point of 15. Let's take a look at problem C. Again, starting off, negative 2 plus 8n with an equal symbol. I'm going to move the negative 2, so add 2 to both sides, and I get 8n equals 4. And now when I divide by 8, I have n equaling 4/8, which is 1/2. That is my boundary point, 1/2. 0 is still on the left side of that. This is going to be now an open circle because it is not or equal to. Testing 0 in my original inequality gives me negative 2 plus, when I put in 0 here, 8 times 0 is 0. Oops, there we go. So negative 2 plus 0 is greater than 2. I get negative 2 is greater than 2. This is false. Negative 2 is not greater than 2. So I do not shade towards 0. I shade now the other direction because 0 does not work. So my solution then on a number line is what is shown. My solution written with an inequality is n. I'm going to the right, so it's greater than. It is not a closed circle, it's an open circle, so I leave it as just greater than, and my boundary point is 1/2. Last problem, part D. 7t minus 4 equals 2t minus 4. Move the 2t to the other side. By subtracting it, I get 5t minus 4 equals negative 4. Adding 4 to both sides, I get 5t to equal 0. And I divide by 5, and I get t to equal 0. So my boundary point in this case is 0. So I cannot choose 0 as a number to test. I'm going to use an open circle because my symbol is not or equal to. And I'm going to take a look at 1. 1 is on the right side. So I'm going to test 1. So when I put in 1, so I have 7 times 1 minus 4. Is that greater than 2 times 1 minus 4? So 7 minus 4 and 2 minus 4 gives me 3 is greater than negative 2. That is true. So since the number to the right worked, I shade that direction. So now that is my answer on a number line. Written with an inequality would be my variable t. Going to the right is greater than. It is an open circle, so I leave it as greater than. And my boundary point is 0. And that finishes up problem 59.